Hello everyone. In this video we are going to talk about sheet metal design in CATIA. In CATIA, if you want to design sheet metals, you go to Start, you go to Mechanical Design, and go to Generative Sheet Metal Design. And this environment has some toolbars related to sheet metal design that you see here. I have basically dragged out of the toolbar place on the right side, right? Tear them off. And the first thing you can do is click on this command here, sheet metal parameters, and set up the parameters for your sheet metal, which is basically the thickness of it, the default bend radius, and so on and so forth. So let's say you want a sheet metal and you want the thickness of it to just be 1 mil, right? And then the default bend radius is typically twice the thickness, so you can make this 2 mils. And then you can provide other information like when it is bending it, what do you want the software to do to the bent area? Do you want it to have no relief? Like this, you can see the sharp corner. So when this part of the edge is bent, there is nothing here, and you see the discontinuity or the sharp corner. While if you say I want the square relief, right, it takes this square part off with dimensions L1 and L2, so you can much easier bend it, or the round relief, or you can have them connect to each other using a linear connection or a tangent connection or anything like that, correct? Then here you can use the K factor, which is calculated already for you, right? So you see it is basically calculated, so you don't really need to change it. I don't think you should change this unless you have a valid reason for changing it, right? And you might ask me, what is the K factor? So here I can explain that to you on this picture that I got from Google. So the K factor is basically the thickness of the material allocated to the distance between neutral axis and basically the let's say the top edge of the material divided by the entire thickness. So if it's 0.5 means the neutral axis should be exactly in the middle of the material thickness. If it's 0.4 means it's a little bit closer to the top edge than to the bottom edge. And then you might say, what is neutral axis? Well, when you bend something, based on solid mechanics that you hopefully learned, a portion of the material, if you do a cross section on the material, a portion of the thickness of the material will be stretched, a portion of it will be compressed. So the portion that is stretched is having positive normal stress. This part has a negative or compressive normal stress, and there is, because the stress cannot change discontinuously, it has to change continuously. So it goes from positive numbers to negative numbers. Somewhere in between there is zero stress, right? So that layer basically does not get stretched or shrunk. So that is where we call neutral axis, the place where there is no deformation, the place that the stress is zero. Okay, so you might be tempted to say it's 0.5, but this formula that you see provided in CATIA, this is based on theories of solid mechanics, so I do not really recommend you changing it. So once I'm set up, I'm done with the setup of the sheet metal. Now I can go ahead and draw a sketch or a profile and then use this command here, which is called wall, and you create a material. So let's say here I go on the top plane, go to sketch, draw a centered rectangle, and then I can go ahead and create a sheet metal inside it, right? So I choose it. It says, hey, is that it? Yes. Do you want it to exactly be on that sketch, or do you want it offset? No, that's good. And I just okay that, and there we go. Here I have a sheet metal of 1 millimeter. If you want, you can apply material to it right now. So I click on here, and let's say it's a sheet metal of aluminum, right? Like this, you can render it with material and see, correct? So it's 1 millimeter aluminum, and now I can do lots of different things on it. Like what? Let's take a look. So one of the things that is very common in sheet metal is to create basically a wall on the edge, or the more common version of it is a flange. So let me show you that. If you want to create a wall on the edge, you click on this command, wall on the edge, and then you choose your edge. And here it provides you the height of the wall on that edge. You see it says 152 mil. Let's say I only want 30 mil. And then you can give it an angle, right? Right now it is exactly going up at 90 degrees, but let's say here, if I look at it from the right side, you see 90 degrees. Now I can change this angle, and I can just make what? I can make a wall at 120 degrees, right? So this is what you have right now. The other thing you can control is the direction of it, so you can reverse it, right? Correct? You can see here positive 120 or negative 120, and you can invert the material side. Okay, right? You want the thickness to be on which side of that edge that you selected, on the left side or on the right side of it. And then you can also give it clearance. Do you want it to have clearance or not? Right now there is no clearance, as you can see here. Just bend immediately, but if I give it some clearance, look. You see here? Now if I increase this distance, you see, it gives it some clearance, some space, then it starts to bend. So it is completely up to you how you want to create the edge on the wall. So let's say here I use 30 mil and 90 degrees, and here we go. There are a few more controls on wall on the edge. So if I go here, one of the options that was checked with bend. And if you remember, if you looked at the cross section, you clearly see that there was a bend here. Right now, if I turn this off, now there will be no bending and no connection between them. And this is kind of like this part, this vertical wall, is a separate piece of sheet metal that you cut, and then you put it on this one. And now you have to connect them together with any method of connection, right? Whether it's welding or any other method to connect them, depending on what material the sheet metal is and how thick it is. You have to use a permanent connection and connect them. Here you have to do the welding, let's say if it's welding on the bottom side, or you can invert it. This is a little bit more reasonable, and now you do the welding on this side. Okay, so one option is with or without bending. The other option you have, if you go to extremities, you do not necessarily need to make that wall on the entire edge. If you want, you can just what? You can just choose a portion of the edge. So here, if I change my, you see, left or right, if I make it positive, it extends beyond the edge. If I make it negative, it is going to move inside the edge. So let's say I want 10 mil on each side to be what? To be left off. I don't want the entire thing. And there we go, right? So these are some more controls for wall on the edge. But this is not the only thing you can do to the sheet metal. One of the commands that is quite similar to wall on the edge is flange. While flange is actually the fact that you're extending this sheet metal in a different direction, and you're making a separate face here for connecting it to another object. Okay, and that connection, that flange, it is gonna be like the part of the same sheet metal, not like this case, a separate one, right? Here you see it's clearly one, this is clearly something else. But if I click on the flange, right, the basic flange is kind of similar to this. So you can choose the edge over which you want to make the flange, you can determine the length, you can determine the angle. It by default has a bend. You can reverse the direction, right? And you okay that. Here we go. So clearly, as I said, this looks quite similar to wall on the edge, with the difference that you cannot really change the length of the edge. Here there is the option called trim support, right? And that is not what you think, okay? It is not going to remove the sides of the edges and make it like this shorter. Okay, so you clearly see what trimming the supports mean, right? It means whether to move the flange outside the edge or bring it inside. Okay, and then you have the option of flange plane, that you can choose a separate plane if you want, correct? If you don't want it to necessarily be the vertical to the edge. You can change the K factor again. I don't recommend it. But this is the basic flange, but there is more to basic flange. If you expand the flange, there is hem, there is a teardrop, there is user flange, and so on. And the most common one is a hem. So hem is not like direction bending in just one direction. It's actually two bendings, or a U-shaped bending, right? So let me show you that one instead of this flange for now, and then I'll show you more stuff. So let's say here, if I go ahead and say create a hem on here, right, and then I provide some distance, like say 10 mil, so it is gonna create this U-shaped connection for me, as you can see. And now you might say, okay, what's the use of this? Well, one of the ways that they connect the sheet metals together is they basically have two parts with hems like this. So there is another part with a hem similar to this, and then they put them opposite to each other, and then they press the hems against each other, and that becomes a temporary connection. Let me show you a picture here. So here you can see that. That's what I meant, but that's not the only one. So it's called flat lock seam. So there is one hem here for one sheet metal, there is another hem for another one. They put them inside each other, lock it, and then they can press against them and kind of create a temporary connection, right? So if they want to separate the sheet metals, they just force them out of the lock. So that's one of the applications of hem that you can see here. Okay, so a few more things. One of the features is called, or commands called, corner relief. And this is when you're forming a corner with bending on two edges, right? Creating flanges or walls on two edges. The matter of fact is, when you work with sheet metals, when you form such an edge, a vertical edge, let's say by forming two, as I said, flanges, there is a good chance that you have tear in the sheet metal due to the bending stress at that corner. Because corners are going to be at that location a sharp spot with a lot of stress concentration. And so cutting that sharp point out and, let's say, making it round, or any other cut like the square that we have, but I guess circular is the best one, that can releases the stress a little bit at that point and avoids tear. So let me show you that. Here we go and create a flange on this edge, let's say for 20, 40, whatever mil, in reverse the direction. Right, and then I do a similar thing here on this one. correct? And as I told you, now if you look at this corner here, you have a sharp spot right there, and that sharp spot is very well capable of creating stress concentration. Now here, the way that the flange is made, it doesn't show it very well, so if we go to any of them and make sure this option of trim support is off. Last time I had it on, so here I'm going to turn it off on both of them, right? So now you can see it a lot better that I clearly have a sharp corner here, and that sharp corner or sharp edge discontinuity is a cause of stress concentration. So for that, I'm going to create a release, and all you need to do here is to choose the two bend areas that will lead to that corner. So for support 1, I choose this one. For support 2, I choose this one. You can choose what type of cut you want. Circular, as I said, is way better than a square. You provide a radius for the cut, 3, 4, 5, whatever millimeter that you want, and then you are going to do the cut. And now, as you can see, that sharp edge that was here, now it is gone, and so now you can alleviate the stress concentration, or that's what we call the stress relief. So there are a few other commands here in this toolbar that are quite similar to part design, like the fillet or the chamfer, right? So if you click on the fillet and then select the edge and then provide the fillet radius, you can make it round. You can also apply a chamfer to it, right? So like here, and you can see that I can apply the chamfer. So very similar. There is the hole command that you can apply, right? And you can make it a simple, basically hole or any other type. And that is, as I said, very, very similar to part design. You can create sketches on the surfaces and do the cut extrude, right? So if I do this and then get out of here and use the cut extrude command, right? So I can do the cut extrude just like this. So these commands, as I told you, are very similar to part design, these guys. Now, one new feature that is one of my favorites is this guy, surface stamp. So you can create stamps on a surface with different types of stamps, and these are used for different applications. Like if you want to deboss something on the part, you can do it. Or let's say, for example, this is the sheet metal for the sink in the kitchen, and you want to make something like the shape of a sink. One of the things you can do is the circular one here. There are other things too, but let me show you. If you apply a circular stamp, and you can define the location of it, and then here you provide the angle, the radius, the height, right? So it is defined using 5 parameters, right? And if you do so, look, now here you have something that is very similar to the sink in your kitchen. Of course, the end of it is not open, but you clearly see, right? It is exactly like using a press and changing the shape of the sheet metal. If I want to create the hole at the end, then I can definitely use the cut extrude or the hole command and get rid of that bottom portion of it, right? So it's no big deal. I can just go and, as I told you here, select this face, go to sketch, choose this guy, project it, get out, and just cut extrude it. Just like that. Done. So, but there are so many other shapes that can make interesting presses for you. There is even one here that you can create a user stamp. So you have to have the stamp or the punch really as a separate object, and then you can use it to create the desired deboss on the object. So that's about the stamp and some of the important commands here. The transformations we had in part design you still have here, like rotation, translation, there is pattern that you can do, and there is the mirror that you can do. So I'm not going to go over them because you can find them in what I did in my part design. The two interesting commands that I want to talk about, one of them is this hopper and the other one is rolled wall. So these are interesting too. So if you want to create a sheet metal that is the kind of shape of like a pipe or something similar to a pipe, correct? You want to create a cylindrical sheet metal basically. Then the way to create that sheet metal, if I want to here show you, is not to create a circle or a disk and then apply the command wall to it, right? So let me show you that. If I go, let's say, to this plane and then draw a circle, or if I draw a disk, right? If I get out, define the parameters, and then use the command wall, and then say, hey, create that for me, it's going to be basically a small disk. It's not going to have a big depth here, okay? So it's not going to do that one. Now you might think, what about the command extrusion? So here we use this one, but as you can see, it says that, it has open elements. It's not just one closed thing, right? It's not just one closed profile, it's just two closed profiles, one inside each other. So if I get out and say, how about this one, and I use the command extrude, still it is not going to like it, okay? So this extrude that you see here is a different type of extrude. This is not the simple extrude that we had in part design, okay? So if you want to create, as I said, a cylindrical section, you can use the command rolled wall, right? And for profile here, if I choose this one, then it is going to create a sheet metal with the same thickness that you specified, 2 millimeters. And then you can say how much the depth of this sheet metal is going to be, and there we go, right? So you clearly see that I can make it completely closed like this, and this is the amount of original flat sheet that I need to cut. Or if I don't want that cylinder to be completely closed because I want to use some operations on it, and then later at the end I connect the two edges together using, let's say, a welding or any other method, then I'm going to change that profile from a full circle to a 3-point arc, which is almost complete, correct? So I can use something like this one, and then something like that, right? And now, as you can see, I have now the gap. And once I'm done with everything I want to do on this, and all the formations are done, now I can push the two edges together, keep them in a fixed position, and then do the welding. So this rolled wall is an interesting feature for creating cylindrical sheet metals. The other one that you can do more complicated than a cylindrical is a hopper. Here you can create a sheet metal, but the sheet metal looks like a multi-section, right? So this cross section of it is going to be different in different depth values, right? So in order to do that, you need to first create a surface. You go to Generative Shape Design, GSD, create a multi-section surface, and then use this hopper to fit a sheet metal to that surface. So let me show you that one as well. So here we go to Shape, GSD, and then create a multi-section. Let's say I go here, and create a square, and then I go ahead, get out, and on a plane parallel to the original plane, I, let's say, create a circle. Let me move this a little bit further back. And then between those two profiles, I can do a multi-section. So here we go. Get out, and now, as I said, I do a multi-section using the two sketches, this one and this one. Make sure the coupling is ratio because the shapes are discontinuous, the square at least. And I make sure I modify my closing points to be in front of each other so there is no twist in the shape. I explained that earlier in part design, so please refer to that for further clarification on removing the twist in a multi-section, or a loft, what we call. So here I bring them both to the center, and then I have this one, and I remove and replace it. So you see I'm trying to put them both on the right plane, like this, and now the closing points are on the same plane. The direction of the attachment of lines, or the connection of lines, coupling of lines, is the same. So now I should not have a big twist. You clearly can see that. And now that I got this multi-section, I should be able to go ahead to generative sheet metal design and use the hopper command and use this for the surface. And if it gives me error, I have to pay attention to what I do. One of the major problems with this is sharp edges. Okay, because sheet metals are bent, not broken at sharp edges. You need to make sure that your multi-section does not have sharp edges like this. So if it does that, you need to go back and fix that square that you made, get rid of the sharp corners, right? So use the fillet command here, right? Let's say I use 20 radius to all of the corners, and then do it. Okay, so there are some considerations. It's not like whatever multi-section surface you give it, it is capable of fitting a sheet metal to it. There should not be any sharp edges. So now hopefully this guy is going to be good enough. The only problem is that now you have to redefine the multi-section. So here I fixed the multi-section, I redefined the closing points, and now you see the sharp edges are gone. So if I go to generative sheet metal design, this time hopefully it is, I was already in it. It is not going to pick on me. So let's see. Now I choose this one, and you see it is giving me the extended version of it, and I can invert it and bring it to the inside of it or the outside of it. And then if I OK that, then it is hopefully going to wrap that cut over the surface and gives me that hopper. You see, it did not do it this time. If I change the direction, let's see if it can do it. Or sometimes you might need to provide an offset or make it the neutral fiber, that surface. Let's see if it can do it. No. How about the neutral fiber? There we go. So it could do it with neutral fiber. And now you can hide this guy, and there we go. You see, you got yourself a sheet metal that is a little bit complicated. And what do you need to cut on a flat sheet of metal to make this happen? You can use the unfold and see, hey, this is exactly what I need to cut. You can make all the measurements You can make drafting out of it and give it to the technician to cut it and then to fold it back together, and maybe at one edge they need to do either a permanent connection or a hem or something and put it together. So that hopper, as I said, and the rolled wall are some very interesting features. A couple of other commands. So remember I mentioned the command extrude and say, although we have this command extrude, this is different than what we have in part design. It is not going to accept the closed profile. So in that aspect, this extrude is very similar to the extrude we have in generative shape design. It accepts an open profile and then extrude it into a sheet metal. So let's say if I go onto this XY plane and then I draw just a simple line, right? If I do that and get out, then I can simply convert it into what? A sheet metal by using the extrude command, right? That's all I need, and I can do it in different directions, different amounts, right? And here we go, right? So as I said, this is very similar to the generative shape design extrude, and this command wall that I did and I applied it to the rectangle and made a sheet metal is very similar to the command fill that I had in GSD. So this is fill, this is the extrude, very similar to GSD. So here I created this sheet using the extrude, and now one of the other useful command is to bend something on a sketch. So let's say I want to bend this, I go ahead and I let's say I want to bend it on a line at angle. So I draw this line, and now I'm going to bend this guy over that line and create the bend sheet metal. So now I choose this guy and it says, okay, what's the profile, what's the line that you have for bending? You say this one, and then it chooses a point on one side of the line as a fixed point. So you clearly know there is this small piece here and there is the big piece here, and since the fixed point here is on the big piece, so the big piece is not going to change its location and orientation. It's the small piece that is going to bend over what? The line, and you can determine the angle that you want it to bend. Let's say if it's 90 degrees, here we go. You see? So now the sheet metal is bend and the smaller portion is bend, not the larger portion. But if I wanted to bend the larger portion and keep the smaller portion in the same place, then all I needed to do was to change the location of this fixed point. So if instead of that point I chose this point, then the small piece is going to stay, the large piece is going to bend. Now you might ask this question that here you bend it over a line. Can I bend it on a sketch other than the line? And the answer is not really, unless it's a combination of lines. So if instead of this one I make it like a 3-point arc, something like this, correct? Say, hey, try to bend it over this arc, it is not going to be happy. It says the profile contains curves, the profile has to contain only lines, right? So if I go back here and instead of this, can I have lines that are broken like this? Can I have a sharp corner? Still not. Why? Because there will be a clash between generated bends. So it is not possible, okay? So the most common thing, as I said, is a single line here, right? Now you might say, what if I put a fillet between these two lines and get rid of that broken corner? Can I do that? Something like this? And the answer is, again, no, because that arc, that fillet is not considered a line. So my suggestion is, really, if it's just in one location, you have to go with a single line, right? If you have sharp corners, then these sharp corners are going to have problems. And here I'll try to make the angle smaller for you. So you see, even if I make that broken part a little bit nicer, still it is going to pick on you. Okay, so I guess I have covered most of the stuff related to sheet metal design for you. And although there are some small other things that you can use, but this is the majority of the commands that are useful, and you can always go ahead and practice it on anything that you have. And as I said, once you apply the material to it, the final product can be rendered very nicely. So thank you for your attention. I will see you in my next video.